Hi, I'm Jingtao Zhang, Calico Big Cats and Microsoft MVP. I work at API 7.0i as the leader of the Cloud Native team. In this talk, I will introduce some security issues in the Kubernetes environment and how to enhance application security through Calico. First, I will introduce my background about the AKS and my application. Second, I will introduce Calico with the AKS, and I will show you security issues in Kubernetes and how to improve security with Calico, and I will show you the future. First, about my company, API 7.ai. The company is Apache API 6, the creator. Our company created many open source projects about API 6 ingress controller. It's another ingress controller in place project named Mesh. It's a service mesh based on API 6. API 6 is the dynamic and performance and cloud native API gateway. And API 7.ai, we based on API 6 create some business product, and we build a product named API 7 Cloud. This is a SaaS product built on Apache API 6. API 7 Cloud provides a simple yet effective and security way to connect your APIs and microservice in multi-cloud environment. Modern enterprise API gateway solution include a data plane and a control plane. The data plane hands traffic and proxy request to the backend, while the control plane manages the instance in the data plane. It will also contain the components such as the configuration, store data, and data plane's configuration. And application performance management helps you measure the health of your API gateway, and users plane will operate the API gateway. Traditional administrator had to maintain both sides, especially the control plane, as it played some roles such as the user portal. Daily operations are tired, and your API gateway may not work as on time for different reasons. API 7 Cloud aims to free people from the management of API gateway control plane. Users will need to deploy their environment as long as the network is connected. API 7 Cloud doesn't touch any traffic of users' business. That ensure user private and security. At last, API 7 Cloud can now help you deploy the necessary service as need you, so you can configuration applications and APIs for the data plane, and you can get the running status of the data plane instance and the data plane's API's cost and something else. Let me introduce why choose Kubernetes. Everyone already knows the advantage of Kubernetes, so I want to introduce them too much. We choose Kubernetes mainly to deploy and deliver applications more effective and improve overall usability. Configurations it can quickly deploy in any Kubernetes environment. Also, API 7 Cloud will run multiple cloud provider. Let me show why choose Azure Kubernetes service. There has two main ways to use Kubernetes on. First is self-managed cluster. You can have more freedom. You can choose the version of you want, as well as the technical solution used. For AKS, the default Kubernetes version is 1.21.23. If I am correct. However, the self-managed maintenance cost and cannot take advantage of some cloud computer advantage. Another option is hosting cluster. You can use AKS, which provides more capability. AKS will move operations ahead of Azure to simplify the operation for user. Since Kubernetes master node, Kubernetes control plane is management by Azure, you only need to manage and maintain the agent node. Therefore, the AKS service is free. You only pay for the agent node in the cluster, not the control plane. So if you want to use AKS, you only one limit is the component selection is limited. How Calico work with AKS? Calico has a good integration with AKS. One create AKS, you can choose by yourself. We have two modes. Calico not only provides the basic capability of network connection, but it also provides very powerful and flexible network policy management capability. Calico can work with Kubernetes or Azure CNI. When creating AKS, you can choose the network mode. If the network mode is selected as Kubernetes, the network policy can be empty or Calico. If you choose Azure CNI, you can use empty or Calico or Azure as network policy. If we use Calico's network mode and policy, we can only use the VCHA line mode only. The IP packages are blocked by AKS infrastructure. Introduce some challenges on the Kubernetes. We will have some problems on the Kubernetes. First one is attack surface increases. Due to the introduction of Kubernetes and some components, the entry system will become more complex, and these components may have security issues, resulting in increasements in the attack surface. The second one is supply chain attack. All applications in Kubernetes are delivered through container image. The container image contains the applications and the runtime environment needs to run. When build a container image, it's usually necessary to use a base image, but it's not easy to, so it's more difficult to keep its security, and it's more easy to get supply chain attacks. Previous escalation includes several reasons. RBAC configuration failed with which is especially in controllers or operators, because they need some permissions to communicate with Kubernetes API server. Network security is mainly due to the fact that when they don't carry their own identification informations, there may be some access. In addition, if TLS encryption is not used, they may also be problems. The next one is resource security. We know that in Kubernetes you can set requests and limits for the pod to limit the resource they can use. But many Kubernetes environment don't have don't set it as a enforced option, so it can sometimes lead to oversold. This may result in pod availability during the mismatch between declared resource and the actual resource used. The next one is data security. Kubernetes provides a config map and secret to store data, but config map is stored in plain TXT, and the secret is only encoded in base 6 form, which is in secret. The data in etcd is also stored in plain TXT, which may also lead to the leakage of the etcd connection string and data leakage in Kubernetes cluster. We know that there are many components in Kubernetes: Kube API server, controller manager, Kube schedule, Kube proxy, kubelet, and others. These components often has CVE issues reports, and we have to upgrade them to address security issues. The last one is runtime security. Runtime security is about protect containers or pods from active threats after they are running. Runtime security helps protect workloads from various threats that may arise after container is deployed, such as attack program hack container image, but it run in your Kubernetes cluster. Why network security is important? Networking is a particularly complex part of Kubernetes. Users can configure the network in several ways. Other components like service mesh, some resources in the cluster may only be connected in the internal network, while others require direct access to the internet. Ports, IP address, and other network properties are often configuration dynamically, make it difficult to attack. We will have some issue when some attack happening in the network level. We will difficult to debug it. Because of these and other complexities, Kubernetes network security is especially challenges. It requires a deep understanding about the Kubernetes networking architectures, as well as familiar with the tools Kubernetes native provides help to protect the network, such as network policy and third-party tools that can hack the network. Although challenges are network dependent, we can't directly block the network connective because microservice architecture there will has thousands of microservices that need to communicate with each other. Next, we will look at how to secure the network in Kubernetes. There is a native way to protect network security in Kubernetes. It is by defining network policy. Define the rules for how pod communicate with each others at the network level. Similar to the ingress resource in Kubernetes, in addition, it needs some actual controller. Network policy needs the support of CNI. For example, Calico supports the configuration network policy, but Flannel doesn't support it. It's a good one. In addition to provide security to control pod communicate, network policy provides the important advantage of allow administrator to define resource and associate network rules based on context such as pod labels and namespace. This is important because, as we explained above, you can't use the IP address to manage network rules due to the dynamic nature of the Kubernetes network configuration. Network policy is similar to Kubernetes RBAC policy. They are fields that especially which network rules to apply, and they also identify the rules, namespace, pod, and some others to which the rules apply, but it may also have some limited. If you have a large number of namespace or want to define a class level, although we can also assist with some other tools. Another one is not provided by Kubernetes, but through application or some other framework can do it. For example, we can enable auto MTLS injection service mesh solutions such as Istio or Linkd to ensure the security of connections between applications. Of course, MTLS can also be used to modify the applications itself, but the cost will be really high. See how Calico protects the network. When using Calico as a network policy engine in AKS, it provides two main resources: Calico's global network policy and network policy resource. The advantage lie in extending Kubernetes native network policy resource and adding support for the priority and order of the resource. We can define global network policy directly without defining a special network policy for each namespace. At the same time, in the native network policy, we can only define the specific allow rules. Calico network policy can define the deny rules. This can be very convenient. Of course, Calico's network policy has very flexible match rules and is more suitable for the complex business applications. Calico can also be well injected with service mesh. How to apply it? We use namespace to isolate business, and you can directly use the global network policy to ensure each namespace is isolated, and then deploy its network policy and the applications. When deploy each service, ensure brings relationship between the network policy and the applications to avoid some security gaps in the cluster. And we can open Azure policy. Additionally, we use Azure policy to automate some policy checks. You may not know much about Azure policy, but it's actually based on an open source project named Gatekeeper. The product injects open policy agent, and Kubernetes natively uses the admission controllers to automatically dynamic some policies. We have the following configuration to force each applications to include the app label, because our network policy will carry out the app related configuration after enable this policy. This configuration is also convenient to manage an application. We can filter some applications by its label, and we can sort the application's label to see which is service. Of course, Azure policy can also have some other things, such as force the inspector of container images for using internal image repository to avoid the use of some external images and reduce the possibility of being attacked. In Azure policy, you can also check whether network policy resource priority configurations and others. This is a very useful tool, and it's recommended to enable it when using AKS. Why we choose Calico? Because Calico have native injection with AKS. When create AKS, we can directly specify whether to use Calico through configuration in the Azure portal or use the AKS CLI, and we don't need to use the extension of the preview version. We can use the in AKS with Calico is the default network as the default network policy. Calico is more powerful description. The Calico network policy and Calico global network policy can be used for our situation. The first, I introduced our SaaS product API 7 Cloud. We will, for multiple tenants isolation, there are various approaches such as provide each tenant with a complex physical environment, but in this case, it will the cost will be high, and at the same time, in our situation, due to the related small amount of user data stored in the cloud, so we just use the network policy to protect the users. And Calico can support network policy, which can greatly improve our security. And in its policy, we can choose to configuration global network policy. It's not necessary to configure it in each namespaces. It will be very convenient, and it has deny rules can be configured, and it's very convenient. Calico has an active community. We can easily get all the resources we need about Calico, including learning measures and so on. And it's easy to find engineers who are familiar with Calico. Calico is a continual evolution. Calico didn't support the eBPF capability as the first. Calico is developing, and the eBPF data plane can replace Kubernetes proxy, retain the client's source IP, and provide high performance. There are very good features. The future, we would like to try in encryptions in the future, which can improve security for us. We also hope to try Calico's eBPF data plane to improve the performance of the proxy. If you have some question, you can find me by my email or Twitter. Thank you.